Okay, so you're able to view my screen, right? Let me open the project on which we were working. So we created the cube yesterday, and we discussed the different types of relationships that we can have between the measure groups and the dimensions. Now the next thing that we would be discussing is how to create different measures, measures in the cube. Um, the reason, one of the main reasons why people use data warehouse for reporting is to view their business metrics against the dimensions. So these business metrics that we have, these are nothing but the measures that we create, and we view these measures or these business metrics across uh, some defined dimensions like dim date, dim geography. So these are the dimensions across which we view the measures, or in the business metrics, like let's say sales amount, that is a measure, and that is a business metric as well. So an organization might want to see the sales amount for a particular product in a particular city for a particular month. So product, city and month, those are all dimensions, and sales amount is a measure. So when we talk about measures, measures are these which are coming from the fact table. Measures are loaded in the fact table. Can you give me a minute? Sorry for the inconvenience. So what we were discussing is um, uh, 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 these measures that we have, these are coming from the fact tables. We have these values in the fact table, but often what we have in these fact tables, these are called as um non-calculated measures. Now these measures that are directly coming from the fact table, that is was always not sufficient as per the user needs. Sometimes the user wants yeah, sometimes the user wants more complex measures, and they want to view some more complex calculations in the reports. So in that case, if the user wants to see more complex calculations in the reports, in that case we create calculated members, and those calculated members are created here in this tab using MDX. Now here is what MDX comes into the picture. While creating calculated members, you need to use the MDX language, because the cube understands the MDX language. So if you're creating a calculated member, you have to use the MDX language. So we'll discuss the MDX language later on, but first of all we would discuss what are the different types of measures you usually come across, and what are the different types of measures you usually create in the cube. Um, the most one measure which always will be added when you create a measure group is this. There will be a measure which will count the number of records in your measure group. So this measure that you see, fact internet sales count, this is not a measure in the here in the table, but when we created this measure group, this measure was automatically created. And similarly for fact reseller sales, we have fact reseller sales count, and for fact internet sales reason we have fact internet sales reason count. Now these measures are nothing but the count of records in this measure group, the count of records in the fact table. Similarly, this is the count of records in this fact table, and this is the count of records in this fact table. So this is the count of records, and this is created by default. And the rest of the measures that you see here if you see the rest of the measures are coming from the fact table. Okay, the rest of the measures are there in the fact table. Now if you there's a difference between, let's say this is sales amount. This sales amount is coming from this sales amount column in the fact table. Okay, now if you see here this measure, if you right click and go to properties, you can see that the aggregate function is count. So it is this, what this measure is doing is, it is doing a count of rows, for this measure group. But if you see sales amount, and if you right click on properties, you see the aggregate function is sum. So what it is doing is, it is adding the sales amount, it is summing the sales amount. If you see, this is the sales amount, and what it is doing is, it will sum the sales amount. Okay, so this is count of records and this is sum. So count of records and sum, these are the two most common aggregate functions which you would come across. 90% of the measures that you would be dealing with, they would be either a count of records or they would be either a sum, because measures are usually additive. So it will be most of the time measures would be either a count of records or it would be a sum. But there are some measures which might have other aggregate functions which we will be discussing later. But these are the two most common types, sum and count. Now let's say if I go to this, let me process this cube. Now I'll just show how this thing works. Now I'll process this. Okay, so I'll process the entire database. Okay, now now let's say let me go to the browser and let me refresh and reconnect. Now once I open the browser, okay, now I have a sales amount in internet sales, and I have a sales amount measure in reseller sales as well, reseller sales fact table as well. So let me pick up the sales amount for reseller sales. So this is the measure that you see here. Now this value that you're seeing, what is this? This is actually sum of this fact reseller sales, sum of this column for all the records. For all the records, if you sum the sales amount, the value that you will get, that you're viewing here. So let me show you this. The reason why it is summing is because the aggregate function of this measure is sum, which is the most common type because measures are usually additive. So what it would do is it would do sum the sales amount for all records in this fact table. And you can see this is the value and this is the same value which is showing here. Okay, Now let me add some more complexity to my report. Now let's see, let me add um, now I have this order date fiscal hierarchy, so let me drop it here. And now let me go to here and let's say Q1. So for July 2006, this is the reseller sales amount. So for here, what it would do is, for all the records where order date key is for July 2006, for those records it would sum the sales amount and display it. So this is nothing, this value that you see, this is sum of sales amount where order date key is for July 2006. This is sum of sales amount where order date key is of August 2006. So that is how it works. Let me check. Now let me run the query and check it. Now let's say I'll go here and sum of sales amount from fact internet sales E, and I'll join it with the dim date table on E dot order date key equal to F dot date key. Okay, so I'm joining this fact table with dim date based on the order date key, and I'll pull only those records where the English month name is July and the calendar year this is for July 2006, right? So I can take calendar year 2006, or July 2006 falls under fiscal year 2007. So I can either take calendar year 2006 or fiscal year 2007. Let me take calendar year 2006 only. And let me run this query. Now the value that you see, 2393689, this is the value 2393689. So what it is doing is, it is summing the sales amount across for the dimensions. Of course, it is summing the sales amount for the dimensions across which you are viewing it. But for those dimension values, whatever records are there in the fact table, for those records it is adding the sales amount and viewing it. Why? And displaying it. Why? Because the sales amount has a aggregate function of sum, and this is the most common type. This is the most common type of measure, because measures are usually additive. So sum is the most common type of measure. Now, fact internet sales count, this is nothing but the count of records. Now, if you look at July 2006, instead of some sales amount, if I want to see what is the count of records where order date keys of July 2006. So let's say I do count star. Okay. So this would give me the count of records in this fact table for July 2006 order date. So let me run this query. There are 1723 records for July 2006. Now if I want to see this in the cube, I have this measure here. If you remember, there's a measure which is always added, which gives you the count of records in that measure group, which is fact reseller sales count. Now if you see here, this is 1723, and here also it is 1723. So these two type of measures that you see, the sum aggregate function and count aggregate function, these are the two most common type of measures you will encounter in everyday life. The two most common type of measures. So now the thing is, but these type of measures are not always the only thing that the users they want to see. The users, they usually want more complex analysis. They want to see more complex kind of calculations. This is the base. Okay, this is the data that you're getting, the measures that you're getting from the fact table. That is the base, but on top of it, users want some more complex analysis. They want more complex calculations. For example, let's say the users might want to see that what is the number of if you look at the this fact reseller sales table, if you look at this table, you have this sales order number and you have the sales order line number. Okay, now let's say for a particular month, the user might want to see what are the number of orders placed in a month. See, the number of this measure will give you the number of records in this table. But like this sales order number has 12 records in this table. What if the user wants to see that in a month, what is the number of orders, what is the number of sales orders placed? If the user wants to see in July 2006, what is the number of sales orders placed? So how would you do that? This will give you the number of records in July 2006. This won't give you the number of sales orders placed in July 2006. So if let's say user wants that data, so how you can do that? You can do that in SSAS very simply. How you can do that is you have to create a distinct count measure. So what you'll have to do is you have to right click on this, or this is fact internet sales. Let's go to fact reseller sales. So you have to right click on this First, let me rename this measure. Let me rename this to reseller sales amount. Okay. Now, as I said, that if the user wants to see the distinct number of sales orders placed in a month. So how you would do that calculation is, you will go here and create a new measure. Right click and click on new measure. And here you can see by default it's selected as sum, because sum is the most common type of measure. Now we have to, these are different options for creating a measure. So we have to create a measure with distinct count, and what it would do is it would do the distinct count of sales order number. You can see this is the sales order number. So if it does a distinct count of sales order number, it will give you the number of sales orders placed in a particular month. So I'll take a distinct count of sales order number and click OK. And now you can see that this distinct count measure is created. The only difference is that you can see that it's created in a different measure group. It has created a separate measure group. Why it has created a separate measure group? Because the granularity of this measure group is different. Here the granularity is at that each transaction level, and for this measure group the granularity is at the sales order number level. So that is why it has created a separate measure group. Okay, and if you right click and click on properties, you can see that the aggregate function is distinct count. Now if I process this cube, I've processed the cube, and now if I go to this and if I refresh, so here you would see a new measure has been added, and that is sales order number distinct count. So I add this. So for July 2006, you can see 1723 is the number of records in the fact table, but number of distinct orders, sales orders placed in July 2006 is 72. And if you run the query here, you can check it from the query. For July 2006, if I remove these measures and if I write count of distinct sales order number, so this would give me the count of distinct sales order number for which order date is July 2006 from the fact table. and you can see this is 72, and here also it is showing as 72. So this is the way how depending on your requirement from the customers, if the customer requires a measure, the customer will tell you that, okay, I want this type of calculation. So you have to think about it, and you have to create that measure in your cube using the existing measures in the fact table and existing dimensions. Now, if it is not possible to do that, then probably you might have to add in a new dimension, or you might have to modify the fact table. Then that's a different scenario. If the present fact table, if in the present fact table and dimension table you cannot do that calculation, then it's a different scenario. You have to modify the fact table or the dimension table. But if it is possible to do that calculation from the existing fact and dimension tables, then you have to use these different types, and you have to create calculated members in the cube and do those calculations. So this is sales order number distinct count. Now let's say we'll go into more details now. Now let's say the user he wants to see the average sales amount per transaction, average reseller sales amount per transaction. So then how you would do that? You cannot create these measures. They are sum measures or count measures. Okay, they do not calculate averages. So how you would calculate? Let's say I want to calculate the average reseller sales amount per transaction for the month of July 2006. So how I would do that? For that I would need to create a calculated member. I cannot create that average calculation here. I have to create a calculated member. This is where the calculated members comes in handy. And when we talk about calculated members, the language that you need to use while creating calculated members is MDX. The calculated member that I will create right now, it is a very simple calculated member. It's a simple division. But sometimes you have to write complex MDX code for some calculated members. So let's say I'll create a to create a new calculated member, you need to click on this. So you have this calculated member. Now I'll give it a name. Average reseller sales amount per transaction. So I want to find out the average reseller sales amount per transaction. So this is a very simple measure. This is the most simple kind of measure that you can create. So all that you have to do is in the numerator you have to pick the reseller sales amount, and then you have to divide it by the count of records in this fact table, which is fact reseller sales count. So if you divide the sales amount by the number of transactions in the fact table, it should give you the average reseller sales amount per transaction. And format string is whether you want to display it in 2 decimal places or 1 decimal places. So let's say I want it to be displayed for this will display it in 2 decimal places, but let's say I want it to round off in 1 decimal place. So I'll do this, and what this would do is it would round this off to 1 decimal place. And the associated measure.
Hey Indra, where did you get retailer sales amount?
Reseller
where did you get the retailer sales amount?
I renamed this. I renamed the sales amount dash fact reseller sales to reseller sales amount.
Okay. Alright, and you're getting those things from dimensions, okay. With metadata, okay.
Okay, and so this the reason why you might be confused is I renamed this measure. This measure, the name of this was actually sales amount dash fact reseller sales.
And that is in which table is that? Which dimension?
Sorry?
Which dimension is fact reseller sales? Okay. Okay.
Fact reseller sales. Okay. So I am dividing this reseller sales amount with the number of transactions. So this will sum the reseller sales amount and divided by the number of transactions. So this will give me the average reseller sales amount per transaction. And I'm rounding it off to 1 decimal place. And the associated measure group, I'll take fact reseller sales only, save it, and then I process the cube.
Hey Indra,
Yeah.
Is the code that we wrote on the cube, is that the MDX code?
This is what I'm writing. This is an MDX expression, but this is a very simple MDX expression. This is just a simple division. Now things can get complex. Sometimes you need to write complex MDX code for some measures. Like for example, if I open the sample solution from Microsoft, if I go to the, let me just show you once. I'm opening this sample solution from Microsoft. Now here you would find some examples where you might see that the MDX code is a little bit more complex, and you need knowledge of MDX to create that calculated member. Now let's say if I go to this cube and I go to calculations, here are a lot of calculated members are created here. Now if you look at internet average sales amount, this is a simple division. Okay, like what we were doing, a simple division. So nothing much here, but let's say if you want to see this internet ratio growth in customer base. So what this is doing is it is trying to find out that what is the growth in the number of customers. Okay, so what it is doing is when date.fiscal.current member.level.ordinal equal to 0, then NA. .level.ordinal equal to 0 means you are at the all level in the hierarchy. I'm just giving you a brief example, like you might find this complex right now. So what it is doing is when you are at the all level, then it is NA. When you are not at the all level, but the customer count value for the previous member. Okay, previous member means, let's say you're viewing the data at the month level. So when you're looking at August 2006, this .prev member will return you July 2006, and this would return you customer count of July 2006. So when I'm writing when is empty this, which means that if the customer count of July 2006 is null, is empty means you're checking whether it's null. So if the customer count of July 2006 is null, then null. But if there is a value for July 2006, so this would give me the current member customer count, which is August 2006. So August 2006 customer count minus this would give me July 2006 customer count, because here I'm using prev member. So August 2006 customer count minus July 2006 customer count divided by July 2006 customer count. So you're looking at this measure for August 2006. Okay, so what the calculation that it is doing is August 2006 customer count minus July 2006 customer count divided by July 2006 customer count. So if August 2006 customer count was 200 and July 2006 customer count is 150, so 200 minus 150, which is 50, divided by July 2006 customer count, which is 150. So 50 divided by 150, that would be the value for growth in customer base for August 2006. Now you can see that things can become complex. In order to create this calculated member, you need a little bit of knowledge of MDX. Otherwise you won't be able to create that calculated member. So we are not getting into those complications right now. I am just showing you some simple calculations. So here what we are doing is we are doing a simple average calculation. We are calculating, dividing the reseller sales amount by fact reseller sales count. And let me process this. Okay, and now let me getting one second. I'm not getting the refresh option. Okay, no issues. Okay, so I've created this measure. And so this is the sales amount. Sorry, let me go to fact reseller sales because we are working on that. So this is the reseller sales amount, and this is the factory seller sales count, which gives you the number of transactions, and you can see that there is a new measure that we have created, which is average reseller sales amount per transaction. And if I'm viewing it against the order date, okay, I'm viewing it against the order date. So now you can see for July 2006, this is the sales amount, this is the number of transactions. So average sales amount per transaction would be this divided by this. And if you look at here, 239, 239, 3689, 2393689.526 divided by 1723. So 1389.25, which is rounded off to 0.3. 1389.3. So this is the average reseller sales amount per transaction. Okay, now let's say if I want to create another measure which will give me average reseller sales amount per order, average sales amount per order, then how I would get that is simply I have to create another calculated member here. I have to create another calculated member here. Average reseller sales amount per order. Okay, this is per transaction and this is per order. And the difference here is, here what you would do is, here you would divide the reseller sales amount, the denominator would change, and you would divide it with, you would divide it by the number of sales orders. So you'll take this distinct count measure. So the sales amount, the sum of sales amount divided by the number of sales orders. So this will give you the average sales amount per order. Okay. And I'll format this to 1 decimal place, and I'll take the associated measure group as factory seller sales only. Display folder is if you want to display the measures under a particular folder, then you can, it's just for display purpose, that these folders will these measures would be grouped under a particular folder, then you use the display folder. So you can see here, we can refresh, and we have a new measure here, which is the average sales amount per order. And this would be this value that you see for July 2006, 33,245.7 is the average sales amount per order. This is per transaction and this is per order. And you can always cross-verify it from the data warehouse. So this is giving you the count of distinct sales order number. And let me copy this. So this, let me take the sum of, I think, what was the name, sales amount. Okay, so this is the numerator and this is the denominator. And let me run this calculation. 2393689 dot 5255 divided by 72. 33245.6, it should be dot 7, 33245.7. So 33245.7. So this is how you create different measures. Now another very useful function that we have in SSAS is like sometimes like in this fact table that you see, in this fact table, the sales amount, there are no records in this fact table where sales amount is null. So let's say select star from this where sales amount is null. So that is not there. There's no not a single record where sales amount is null. So when I'm creating this average of sales amount, it's not an issue for me. But let's say there if you have some records, if you're creating an average value for a measure and there are some records in that table where that average value where that measure value is null, then how would you handle it? Like this is a common scenario which I have encountered in many production in many projects, is that we are creating an average measure, a measure which gives us the average value, and that measure has null values on in some of the fact table records. So what to do? Ideally, when you're calculating an average value, so if you have null values in some of the fact table records, the general way to handle it is to ignore those records where you have null values. So when you're calculating the average, if there are some records in the fact table where that measure value is null, then we generally ignore those records where it is null. So how to do that? Because the kind of calculation that we have done here, this would give you the count of all records, even the null values, even the records where the measure value is null. So this would give you the count of all records. But if you want to ignore those records where the measure value is null, how would you get the count in that case? So in that case, what you do is there is a good function available in SSAS. So let's say, for example, what I have done is I have updated some the tax amount. I want to calculate the average tax amount, and by default in this table there were no records where tax amount is null. So what I did is I updated some records where tax amount is null. So you can see here, there are 188 rows where tax amount is null, and I want to calculate the average tax amount per transaction, but I want to ignore these records where tax amount is null. So how I would do that is, if you want to ignore the some records where the measure is null, for that SSAS has a very good function which we can use. So what we'll do is, if we here for factory seller sales, we'll create a new measure, and here we'll select count of non-empty values. So we'll select count of non-empty values, and here we'll select tax amount. So what this would give me is, this would give me the count of records where tax amount is not null. And that is what we would be using as a denominator in our average calculated member. So this is giving me count of non-empty values for tax amount, and you can see it gives me tax amount count. Okay, so let me so what I'll do is, and this is sum of tax amount. If you look at the properties here, this is sum of tax amount. So when I'm calculating the average tax amount per transaction without ignoring ignoring the records where tax amount is null. So in that case, what I'll do is I'll go to calculations, I'll create a new calculated member, average tax amount per transaction. Okay, now what I'll do is let me reconnect this, and I'll take this, this as the numerator, and then divide it with the it's not showing yet because I haven't processed it as yet. So okay, let me do one thing. And let me process the cube. Okay. So I've created this new tax amount count measure, and if I go here and I'll create a new calculated member, average tax amount per transaction, or let me write per tran. So then what I'll do is, here I'll take this tax amount, still not visible. Why is it so? Yeah, this is the tax amount count. Okay, so this, what this would do is, this will sum the tax amount for the transactions and divide it by the count of records where tax amount is not null. So this will give me the average tax amount. And if you want to make it visible, you can make it as true. If you don't want to make it visible in the reports, then you can set it as false. And select the measure group.
What is on the non-empty behavior?
Non-empty behavior is kind of, it is not mandatory for you to use it, but it helps SSAS in performance. So what you mean to say is, non-empty behavior is, let's say if you specify here that tax amount, if you specify here, no, not this tax amount, tax amount is this, yeah, this one. So what you are specifying to SSAS is, it helps in query performance. So what you are saying to SSAS is, if the value of this measure is null, if the value of this measure is null, then this measure will also be null. So it SSAS will automatically, what it do is, it would automatically ignore those records where this value, so it will help in processing. It's nothing, it doesn't help in any way. It will only help in query performance. When SSAS is running the query, when it encounters records where this value is null, non-empty means non-null. In MDX, empty is null, non-empty is non-null. So when it will encounter values where this value is is null, then it means that what it would do is, it would then immediately skip it and only consider records where this value is not null. So it won't take those records into calculation where this is non-empty. So it helps SSAS in query performance, nothing else. Even if you don't specify it, even then it will work. It just helps in query performance if you specify it. Okay. So when the tax amount, this value is null, so it won't be considered in the summation as well. It won't be considered in the numerator, and it won't be considered in the denominator as well, because we are taking only the count of records where tax amount is not null. So records where tax amount is null, that won't be considered in the numerator, that won't be considered in the denominator as well. Because when you're adding tax amount, if there's a null value, it won't add. The value won't be add. The value won't be we won't increase if it's a null value. So when this value is null, those records don't add to the numerator, they don't add to the denominator as well. So they can be safely ignored while calculating. So it kind of helps at the time of processing. I mean, not at the time of processing, at the time of query performance. So these are some of the very basic measures, I would say, and you can build more. You can build more on these measures. Um, when you have the need to create a complex calculated member, the base measures will be this only, but using these you might have to create some calculated members here. And sometimes you might need to use some of these different options to create a measure. So now the next thing that we would be discussing is the next thing that we would be discussing is semi-additive measures. So let's take a 5 minutes break and then we'll come back and we'll discuss. Okay. Okay, so what we were discussing, we discussed how to create a few measures. Now we would be discussing a concept called semi-additive measures. Now, the measures that we have talked about till now, these measures are additive in nature. So, and that is so these measures are one second. Okay. So most of the measures that you will come across, they are additive in nature. But there are some measures which are semi-additive, and there are some measures which are non-additive. So non-additive is very rare. I would say you would find non-additive measures very rarely, but semi-additive measures are kind of you can say if 90% of the measures are additive, you can find 8 to 9% of measures as semi-additive. Now there are differences that when we talk about additive measures are when you consider the date dimension, when you go to a higher level in the hierarchy, additive measures adds the values to the higher level. Like for example, what I mean to say is this is an additive measure. So when you're looking at July 2006 August to the sales amount, July 2006 sales amount, August 2006 sales amount, September 2006 sales amount, and when it is going to the quarter level, it is adding these three values and displaying at the quarter level. So it is an additive measure. When you're viewing at the year level, it is adding these four values, for adding the value of 4 quarters and displaying at the year level. So this is an example of an additive measure, and additive measures are the most common type. You can say 85 to 90% of the measures are additive. But there is another type of measures called semi-additive, which are also there. They are less, but it is there. So how the semi-additive measures behave is like well, let's say you have a measure. I'll give you an example. You have a measure which displays your bank account balance. Okay. Now the bank account balance at the end of July 2006, it is, let's say, $40,000. At the end of August 2006, it is $20,000, and at the end of September 2006, it is $10,000. So when you look at quarter one for that measure, do you want July, August and September values to be added and displayed at the quarter level? Does it make sense? It does not make sense. When you talk about bank account balance, if you add the three values of the months and display it at the quarter level, it does not make sense. Similarly, at the year level, if you add the balance for the 12 months and display it at the end of the year, it does not make sense, because that is not an additive measure. That is a semi-additive measure. That's not an additive measure. So ideally what you would like is July 2006, this is the balance. August 2006, this is the balance. September 2006, this is the balance. So for quarter one, you might want to see what is the balance at the end of September 2006. You want that to be displayed for quarter one FY07. And for FY 2007, you would like to see what is the value at the end of June 2007, because that is the end of the fiscal year. At the end of the fiscal year, what is the value of that measure? That should be the value at the year level. So then this is not an additive measure. This is a semi-additive measure because it is not additive across the date dimension. Semi-additive measures are by definition, additive measures are additive across all dimensions. Semi-additive measures are additive across other dimensions, but they are not additive across the date dimension. That's a semi-additive measure. Non-additive measure are those measures which are not additive across any dimension. All the dimensions that you have, they are not additive. So that's a non-additive measure, which is very less, I mean very rare, I would say. A measure which is not additive across any dimension, that is rare. So, but semi-additive measures are there. If you talk about bank account balance, if you talk about your stock, what is the end of the inventory stock at the end of each month? So you won't like to add that at the quarter level, or you won't like to add that at the year level, because that is the balance at the end of the quarter, that is the balance at the end of the year. So you don't want to add that. So semi-additive measures are there, like when you talk about stock, inventory stock, when you talk about account balance, when you talk about, let's say, outstanding SRs. In our case, we had a measure called outstanding SRs, which were a semi-additive measure. It gave the count of SRs outstanding at the end of every month. So when you talk about when you go to the quarter level or year level, it should not add the outstanding. It should give the outstanding at the end of that quarter or the end of that year. Similarly, active assignments, that is also a semi-additive measure. So there are some, let's say, share price, the stock price that you have. If you're displaying the stock price as a measure, it won't be additive. The stock price at the end of January, or at the end of February, or at the end of March, then when you look at the quarter, will you add those three values and display the stock price for the quarter? No. Or for the year, will you display the stock price by adding all the stock price values at the end of every month? No. So those are semi-additive measures. So how you create in semi-additive measures also, there are different types of semi-additive measures. There are different options under semi-additive measures. So I'll show you that. Now, let's say in this case only, I want to create a sales amount. Here in this case, this is additive. It is adding these three values and displaying at the quarter level. Now let's say, for example, I want to create a semi-additive measure which will pass the last value, which is September 2006. It will pass this value at the quarter level, and at the year level it will pass the sales amount at the end of that year, which is I would say June 2007. So at the end of that, it will that would be the value for the year. So how to create that kind of a measure? So if you want to create that kind of a measure, what you have to do is you have to right click on this, click on new measure, and here in usage I would select last non-empty value. I could have selected last value as well. If I select last value, then it would take the last value in that level, with even if it is null, it would take that last value and then pass it on to the higher level, even if it is null. If I take last non-empty value, it will take the last non-null value and pass it on to the higher level. So what I mean to say is, if June 2007 value is null, and if I take last value, then for quarter 4 the value would be null, and for fiscal year also the value would be null, because June 2007 has null value. But if I take last non-empty value, if June 2007 has null but May has a value, so then quarter 4 will take May's value, and FY 2007 will also take May's value. So that is the difference between last value and last non-empty value. Similarly, we have first value and first non-empty value. So you can also take, if you have a requirement where you want to take the data from the first month, you want to pass the data of the first month to the quarter level, or the first quarter to the year level, or the first month in the fiscal year to the year level. So that option also you have. You can select first value or first non-empty value. So let's say I'll take last non-empty value, and the measure would that I'm aggregating, that's sales amount. So I'll take last sales amount. Okay, and if you see here in properties, it's showing as last non-empty, the aggregate function. And now if I process the cube, and okay, now let me go to this Excel file and let me remove these measures from here. Factory select. Now let me keep this. This is an additive measure, so I'll keep this one, and let me pick up the new measure. Why it's not showing? Yeah, this last sales amount. So now if you look at here, what is happening here is, see, when you're looking at April, when you're looking at, let's say, let's take up quarter 1, so July, August and 2006. So in this case, this is the value for July, this is the value for August, this is for September. So at the end of the quarter, this is the value, and this is being passed at the quarter level. So here in this case, it is addition of these 3 values at the quarter level. Here in this case, it is the last value which is aggregated to the quarter level. Now when we talk about year level, here it is addition of all 4 quarters at the year level. Here the last value of that fiscal year is being passed at the year level. So this is a semi-additive measure, this is an additive measure. And I would like to format this. So if I want to format it, what I'll have to do is I have to right click on this, go to properties, go to format string, and I can select this. To format it to 1 decimal place. Okay. So if you go here and you do a refresh, now we can see it's rounded off to 1 decimal place. Now this is what it is doing is it is passing the last value to the higher level of the hierarchy. Okay, last value of the children. Now that is last non-empty value or last value. Now there is another type of semi-additive measure which is also very common. Sometimes what they want is, what your customers would want is, here what it is doing is it is passing the last value at the quarter level or last value at the year level. But sometimes your customers don't want the last value. They want the average of these values at the higher level. So what I mean to say is, when you're looking at see, July, there's only one data. There's what I'm saying is, this is the lowest level in the hierarchy. Okay, so this is the sales amount. So when from the day level you're going to the month level, there's only one value. So there's nothing to average. One value, so there's nothing to average. One value, the average would be the same for August 1. There's nothing to average. So this will pass on to the month value, this will pass on to this value, and this will pass on to this value. But when you're looking at the quarter level figure, what it will do is, it will, here in this case it is passing the last value to the quarter. But instead of passing the last value, let's say you have a requirement where your customer says, I don't want the last value, I want the average value of these children. So in case of that, what it will do is, it would do an average of its children. So average of children at the lowest level. So for the quarter there are 3 values, this, and this. So it will do an average of these 3 values and display at the quarter level. And when you talk about the year, in the year also, I haven't expanded this. In the year also, it has 12 values for fiscal year 2007. So what it will do is, it will do an average of those 12 values and display at the year level. that is called an average of children, and it will do the average of the values at the lowest level of its children. So if we want to create that sort of a measure, how we create that is, here we create a new measure, and here we select average over time. Average over time, and I'll select sales amount. So this is saved, and let me rename this to average sales amount of children. Okay, and if you right click and go to properties, you'll see the aggregate function is average of children. So if you process this, and you go to refresh here, you have the new measure, average sales amount of children. Now if you see here, what it will do is, for the quarter level, you have 3 children at the lowest level, this, and this. For the month level, you have only 1 children, so the average will be the same. Here also 1 children, average will be the same. Here also 1 children, average will be the same. When you go to the quarter level, it has 3 children at the lowest level. So what it would do is, it would do the average of these 3 values and display at the quarter level. So this value is 239.3689.526 plus this value is 3601 190.714 plus this is 28853 59.199 2885359.199, okay, equal to this divided by 3. So this is the value, and you can see that this is what is displayed at the quarter level, 2960079.813. Now if you go to the year level, this value that you see, this is the average of all the 12 values. These 12 values that you see here, these 12 values that you see here, it is the average of all these 12 values when you look at this year level value. So this is another type of semi-additive measure which is called average of children. Any Any doubts? Any doubts or any questions? Okay. So this is what I had to discuss about the measures. Now the next thing, it's a very small topic, won't take a long time. What I would discuss is write back. It will only take 5 minutes, 5 or 10 minutes. So there is an option in SSAS which we call as write back. So the write back feature, it is disabled by default. But let's say you are creating reports for the CEO of a company or a person who is at a very high position, and when he is viewing the reports, let's say at the time of viewing the reports, at that time only he wants to make some changes to the reports. Let's say he has a client meeting. Okay, he has a client meeting, and at the time of when he's viewing the report, at that time he wants to make some change to the report and then show it to the client. Okay, so we have to give him that right, him or her, that right to change the reports. So though this is a very privileged right, you would probably have doubts that why would I allow someone to mess up the report? Why would the report that is being generated, that is being generated out of actual data. So why would I allow someone to mess up the report? But sometimes if the customer wants that privilege, if the customer wants that right, that okay, I am viewing this report, I want to change something, I can do it right away from that report only. So if the customer wants that kind of privilege or that kind of right, then you have to enable write back. There's a feature called write back in SSAS. So what the write back feature does is, I'll show you in dim customer. Let's say, let's open this dim customer table, and if you right click on this and go to properties, you see this write enabled option. This is set to false. So by default this write enabled option is set to false. But let's say you want to give privilege to some of your customers to be able to write back. So what you have to do in that case is you have to set this property to true. You set this property to true and save it. Now you've got to process this dimension. Okay, so you have processed this dimension and you have made the change. You have made write enabled to true. Now let's say that particular user is browsing this dimension. Okay, he goes to customer, and let's say he is John V. Yang, and he wants to change his surname to whatever. Let's say he wants to change his last name to Yang 123. So if you haven't enabled write back on this dimension, he won't be able to do that. Now let's say he wants you have enabled write back. So now what he can do is he right click. You can see this write back option. Otherwise this option would have been grayed out. Since we have set it to true, you have the write back option. So you click on write back, and now what you can do is you can set this to Yang 123. And now it says, it gives you Okay, so this is this is another error. Now let's say I go back to this is a named calculation that we are using. Now let me go to the last name. Okay, and here I want to change it. I want to change this to Yang123. Okay, now it's giving me this particular error. Why it's giving me this particular error? It is very difficult to understand why it's giving me this error. This reason is the multiple active result set is not enabled in the data source. In order to make writeback work in the data source, there's a property which you have to make true. So let's go to the data source. Because when you do a write back, when you change this Yang123, this will be changed in the table also. In your data source, in this dimension table, the last name will be changed to Yang123. So you go to all, and there's a property called a Mars connection, multiple active result set. So you've got to set it to true. Click on OK. Click on OK. And now I have to process this again. And then I go to dim customer, I go to browser, go to customer, I go to member property and last name. Sorry, I have to write back Yang123. And now you can see that this I have changed the last name of this customer to Yang123. Okay, now I am a user. Now if I go here, go to the browser, refresh, reconnect, and you can see if I go to the customer, so it is showing as John V Yang123. So from the browser itself, I'm a user. From the browser itself, I changed the last name of this customer to Yang123. And if you look at the what was the key of this customer, if you sorry, it was 11000. Okay, so if you look at the table here, you will see that the change has happened in the table. It has directly made that change to the table. So if you look at dim customer, select star from dim customer, where the customer key is 11000, I guess. And you can see here that this is first name John V and the last name has changed to Yang123. So I made this change from the browser itself. I enabled the writeback. So if you enable the writeback on a dimension, the user who is accessing that dimension, they can write back or they can make modifications. And the table also will get modified. And if you want to do a write back on your measures, if you want to do a write back on the measures, then you have to go to this partitions, and in the partitions you have to right click and go to this write back settings. So that is what we call as write back.
Indra,
Yeah.
what kind of modification you made on the data source?
I didn't make any modification to the data source. I just went to the dim customer. Oh,
But,
you mean
you
the
are
property? The
yeah.
property. Yeah, the property was Mars, M-A-R-S, Mars connection. So the property is this one. MARS, Mars connection, that has to be set to true for writeback to work. If you haven't set that property to true, then writeback won't work.
What is that Mars connection?
Mars is multiple active result set connection. So what you mean to say is the person, he will have the right to write back into that table.
Oh, okay.
Okay. And so that is what we had to cover today. There is nothing more. Tomorrow we would be discussing partitions and storage modes. So any questions you have regarding what we have discussed today?
Oh, will you show us any things like related to the real environments, related to the real job environments?
This is like the kind of measures and the kind of the database that you have here. This is kind of very similar to the real environment. Like you will only have to create these kind of measures and all in the real environment, because see, the real environment, for that you would need that kind of a database and that kind of requirement. If someone gives me a database and someone gives me some requirement, okay, I have to do this, based on that I'll create the solution. But this is this is quite close to the real projects. Like these kind of calculations and these kind of dimensions you will have to create in almost all SSAS projects in real time. This is what I am showing you here. This is very close to what you will do in real time projects. So in a real-time project also you will have dim date, you will have dim geography, same things you will have. There also you will have to create this type of hierarchy. There also you will have a calendar hierarchy, you will have a fiscal hierarchy. You will have the measures there and you will have to view those measures. You might have one or two semi-additive measures. So the same things you will have in your real-time project as well. But yes, while implementing the real-time project, you have to apply your own knowledge and your own you have to apply your own knowledge and own concept and your own intelligence to implement that. But the basic knowledge, but the basic thing would be the same kind of dimensions would be there, and the same basic concept. I'm just giving you the concepts and the basic things that we usually do in real time. The same things you will do in real time as well. Like today I showed you semi-additive measures. Like in my in the projects, in the real-time projects that I've worked most, there have been instances where semi-additive measures were required. It was not very common. Maybe only 10% or 5% of the measures were semi-additive. Rest of the measures were all additive measures, but there were 1 or 2 measures which were semi-additive, so I had to create semi-additive measures. So you need that knowledge and concept how to create semi-additive measures. Now if you have that knowledge and concept, then you can go ahead and create any semi-additive measure. Okay, so any other questions? Okay then, so what I'll do is we'll end today's session, and I'll upload the video of this one as well as the previous video. I was facing some network issues yesterday while trying to upload. That is why I was not able to upload. Okay. Okay then, thanks a lot. Thanks everyone.